Okay, so in our previous segment, we looked about how stars form. Now we want to look at how solar systems form. And in particular, we're going to be talking about our solar system. So, about 5 billion years ago, a gigantic gas cloud, 10,000 astronomical units in diameter, began to contract due to gravity. So 10,000 astronomical units in diameter means that this thing would have extended halfway to our closest star, Alpha Centauri. So it was huge. Now, this gas cloud was made up of primarily the gases hydrogen and helium. So it would have had, roughly 75% hydrogen, and then it would have had about 25% helium, and then it also would have had some other gases in there as well. Then it also would have had some ice in there. Now, the kind of ice could have been water ice, it could have been carbon dioxide ice, it could have been methane ice. So different kinds of ices were also present in this cloud. But it was roughly 99% gas with about 1% everything else. And that 1% would have included these ices and dust. And the dust would have been composed of silicon compounds and iron compounds. So that's what the original gas cloud would have been composed of. All right, so now this thing is going to start to collapse. Now, initially, it's going to be rotating very, very slowly. Okay, but I want you to think about what happens to an ice skater when an ice skater is spinning and then they draw in their arms. What happens to them? They speed up. So this cloud is going to begin to speed up as it is contracting due to gravity. So what's going to happen to these particles? Well, I just happen to have with me a orbital simulator, which actually looks remarkably like a hula hoop, but this is going to simulate the orbits of these different kinds of gases and particles. Okay, so that originally you might have had some of the gases could have been orbiting like this, and then some of them could have been orbiting like this, and then some of them would have been orbiting like this. So you have all different kinds of orbits for the gases and the dust initially, but then they start to collide. So as the gas and the dust and the ice begin to collide with each other, they start to change the direction in which they're going. So imagine that you have a car that's going in this direction, and then you have another car that's going in this direction, and then they collide. What direction do they tend to go in after the collision? Well, they tend to go in this direction. So that initially you had particles that were orbiting like this, and you had some that were orbiting like this, but then after they started to collide with each other, they begin to orbit like this. And so you can see that they start out being a spherical cloud, but now they're starting to become a disk. Now the middle part of the disk is where the sun is going to be. The outer part of that disk is where the solar system is going to be. All right, so let's keep going here. So then the next thing that's going to happen is that the ice and the dust particles are going to begin to be distributed in different parts of the solar system. So initially, in this disk, you have a uniform composition of dust particles and ice particles and gas particles. Okay, but the center part of the disk is going to start to get hotter. So remember that when the universe expanded, it got cooler. So that means that when something contracts, it has to get hotter. So the central part of the solar system is going to get hotter and hotter and hotter because it's collapsing, and that's what's going to turn into the sun. But we're not really interested in the sun part. We're interested in what happened to the disk part. So that's going to become the solar system. So what starts to happen is that, let's pretend that this is where the sun is at, and it's starting to get hotter. A certain region starts to develop around it, and we're going to call this the ice line. Another name for this is called the frost line. So inside of this ice line, it's going to be too hot for ice to stay there. So the ice will evaporate if it's inside the ice line. So that means that the ice, I for ice, is going to be driven into the middle and outer part of the solar system. So what does that leave you with in the inner part of the solar system? Well, you're going to have some gas there, but we're not really interested in the gas. We're interested in the rock and the metal that was in this area right here. So that is eventually going to become the cores of the terrestrial planets, such as Earth and Mars and Mercury and Venus. So all of those planets are going to develop in here because they're going to be composed primarily of rock and metals. Now out here you've got rock and metals, and you're going to have ice out there as well. All right, now the next thing that's going to happen is that the dust particles are going to start to collide with each other, and initially they're going to stick together because of electricity. So imagine that you look underneath your bed and it's all dusty under there, and then so you clean it very carefully. But then you go back 6 months later and you look under your bed and there's dust bunnies. So the dust particles have collided with each other and have stuck together because of static electricity. So that's what initially is going to happen to the dust and metal particles. They're going to start to collide and stick together. So now maybe you've got little chunks of rock and metal that are about this big, and then so they're going to start to collide, and now you've got chunks of rock and metal the size of your fist. Well, by the time that they get to the size of a basketball, about this big, then they've got enough mass that they begin to stick together because of gravity. So initially you might start out with trillions of dust particles, but eventually that's going to turn into billions of particles that are maybe this big. And then that's going to turn into millions of particles that are going to be the size of a house. So every time these things are colliding with each other, you're ending up with a larger and larger object, and eventually we're going to make planets from this. And we're going to call them protoplanets because they're not quite planets yet, but they're in the process of being formed. Now, the next thing that's going to happen is you have your inner planets. So this is like Mercury and Venus, Earth, and Mars are going to be composed of rock. And then out here, you're also going to have protoplanets that are going to be composed of rock and metal. But out here, you also have ice. And so this ice is going to start to accumulate on these objects out here because of the gravity. So now, in addition to rock and ice, in addition to rock, these things now have ice that's starting to collect around them. So that makes them a little bit bigger yet. And so the next thing that's going to happen is, remember, there's gas out here. There's gas in here, there's gas out here, but now these things are bigger, so they start to accumulate gas as well. And as they accumulate that gas, they get bigger still. And so these things eventually turn into the Jovian planets. So now you've got Jupiter and Saturn, Uranus, and Neptune. Okay, now what about way out here? So way out there, you could still have some rocky objects out there, but there's not so much gas and there's not so much ice in this outer part here. So that means that these things are very, very small, and an example of that would be Pluto is out there. So it was just so far out in the solar system that there wasn't any materials for it to work with out there. Okay, now the next thing that's going to happen though is finally the sun is going to turn on. So the sun is going to get so hot it's going to reach that critical temperature of 10 million Kelvin, and it is going to ignite. And then when it ignites, it has what's known as a solar wind. A solar wind is going to be the particles that are being blown off of the sun, things like protons and electrons. And then what happens is that wind is going to blow all of the remaining hydrogen and helium and other gases out of the solar system. So that what you're going to be left over with is rocky planets here, and then your gas giants out here, and then way out here, just kind of like the rubble that's left over from the formation of the solar system. Okay, let's take a break, and when we come back, we're going to talk about density.